Alright, hello and welcome to the third video in the flipped classroom. We're going to be talking about right triangle trigonometry in this packet. So, quick overview of what you're going to learn. You're going to be able to evaluate trigonometric functions of acute angles, use fundamental trigonometric identities, use a calculator to evaluate trigonometric functions, and use trigonometric functions to model and solve real-life problems. Okay, so in a right triangle, we have a right angle, and theta we typically refer to as another angle in the triangle, and it's going to be an acute angle. And now theta is here. We call the side next to theta adjacent. We call the side opposite of theta opposite, and we call the hypotenuse of the triangle the hypotenuse, because we already know the longest side in a right triangle is called the hypotenuse, so we're not going to change the name up. And sine, it can be found by doing the opposite side divided by the hypotenuse, cosine, adjacent to side divided by the hypotenuse, tangent, opposite divided by adjacent, and so forth with their reciprocals. Just swap the numerator with the denominator. Alright, so first we were talking about trigonometric functions using the unit circle. Now we're going to consider right triangles. Alright, we got the hypotenuse, the opposite side, and the adjacent side. Those are the three sides you want to get familiar with in a right triangle. So let's form first the six trigonometric functions of the angle theta. Okay, so if theta is in a right triangle, like we said earlier on the front page, sine of theta is the opposite side divided by the hypotenuse, and we tend to abbreviate it like this. Cosine is the adjacent side divided by the hypotenuse, and tangent of theta is the opposite side divided by the adjacent side. Similarly, their reciprocals. Cosecant is going to be the reciprocal of sine, so this one's going to be the hypotenuse divided by the opposite side. Cosine is going to be the reciprocal, cosecant, or secant, secant is the reciprocal of cosine, so that's going to be hypotenuse divided by the adjacent side. And cotangent is the reciprocal of tangent, so we're going to get the adjacent side divided by the opposite side. Sorry, this is SEC. So let's use this triangle to find all six values. Now notice the hypotenuse is not found, so we're gonna want to find that first, because both sine and cosine, cosecant and secant all need the hypotenuse. It's a right triangle, so we can find the hypotenuse using Pythagorean theorem. The Pythagorean theorem says a leg squared plus a leg squared is hypotenuse squared. So in this case, one of the legs is 3, another leg is 4, and we want to solve for the hypotenuse. So we're going to get 9 plus 16 is the hypotenuse squared, or 25 is the hypotenuse squared. And if we square root both sides, we actually get plus or minus 5 is the hypotenuse. But since we're dealing with a triangle, it's a distance, we're going to choose 5, positive 5, to be the length of the hypotenuse. So now that we have all the information we need, let's find sine, cosine, and tangent. So sine of theta is opposite divided by hypotenuse. So in this case, that's going to be theta's here. So the opposite side is 4 divided by the hypotenuse, which we just found to be 5. So sine is going to be 4/5. Cosine of theta is the adjacent side divided by the hypotenuse. So in this case, that's going to be 3 divided by the hypotenuse, which is 5. So 3/5. And tangent of theta is going to be the opposite side divided by the adjacent side. So that's going to be 4 divided by 3. And then the reciprocals. So once we already know sine, we could just take the reciprocal and just get 5/4 for cosecant. Or you can use what we defined above. It's the hypotenuse divided by the opposite side, so 5 divided by 4. But I'm just going to use the reciprocal since we already did all that work finding sine, cosine, and tangent. So secant is just going to be the reciprocal of cosine, which is 5/3. And cotangent is just going to be the reciprocal of tangent, so 3/4. Okay, now let's say we're working on example 3. Find the exact values of sine of 45, cosine of 45 degrees, and tangent of 45 degrees. Look, both of these angles are 45 degrees, so it's not going to matter which one you focus on. I'll focus on this 45. It doesn't matter though. Sine is opposite divided by hypotenuse, so it's going to be opposite side is going to be 1. Hypotenuse is going to be root 2. So sine of 45 equals 1 over root 2. But we're going to want to rationalize that, so we're going to multiply by root 2 over root 2 to get root 2 over 2. Cosine of 45 is going to be adjacent over hypotenuse, and look, it's the same thing, 1 over root 2. So I know after rationalizing it's the same thing, so I'm going to get root 2 over 2. Tangent of 45 degrees is going to be opposite divided by adjacent, so 1 over 1. 1 over 1 is 1. Alright, now we've got to find sine, cosine, sine of 60, cosine of 60, sine of 30, and cosine of 30. So 60 is over here, so let's find sine of 60. 60 is here, so the opposite side is going to be root 3, hypotenuse is going to be 2. So sine of 60 degrees equals root 3 over 2. Cosine of 60 degrees, well, that's adjacent over hypotenuse, so that's going to be 1 over 2. So that's going to be 1 over 2. Now, sine of 30, now we're focusing on the 30 degrees and taking sine. Sine is opposite over hypotenuse, so that's going to be 1 over 2. Cosine of 30 is going to be the adjacent side of 30, which is root 3 over the hypotenuse, which is 2. So notice we have a fun little property there. Sine of 60 and cosine of 30, those are the same. And cosine of 60 and sine of 30, those are the same. So sine and cosine are called cofunctions. And when you have, if you take the angle, the cosine of one angle, say 60 degrees, and sine of the complement of that angle, 30 degrees, you're always going to get the same answer. So like if you took cosine of 50, that's going to be the same thing as sine of 40, because the cofunction identity says that if you take cosine versus sine of complementary angles, your outputs will be the same. Now these are just special angles. You can choose to memorize these or not. All of these angles are found on the unit circle, so you could use a unit circle to solve for these, or if you would rather just memorize all of these, you can do that as well. However you want to do it, eventually you're going to want to be able to find sine of 30 or cosine of 45 or tangent of 60 without using a calculator. So that means either memorizing or using a unit circle to derive those. These ones are very commonly used, so that's why we have them here in our notes. Okay, some identities. So reciprocal identities go as follows. If we have sine of theta, that's actually equal to 1 divided by cosecant of theta, because they're reciprocals, right? If cosecant's the reciprocal of sine, think about it this way. It's like dividing by 1 over sine, which is multiplying by sine. Similarly, cosine of theta is 1 over secant of theta. And tangent of theta is 1 over cotangent of theta. Because, again, guys, this comes back to sine being the reciprocal of cosecant, cosine being the reciprocal of secant, tangent being the reciprocal of cotangent. So we could also write these in this form. Cosecant of theta equals 1 over sine of theta. Secant of theta equals 1 over cosine of theta. And cotangent of theta equals 1 over tangent of theta. They're reciprocals in either way you go. So these are 6 different identities. Now, the quotient identities, those involve sine, tangent and cotangent. Tangent, instead of being thought of as the reciprocal of cotangent, you can actually think of this one as sine of theta over cosine of theta as well. While cotangent of theta could be thought of as cosine of theta over sine of theta. Okay? Pythagorean identities, they all come from this main one, sine squared of theta plus cosine squared of theta equals 1. And you can get the other ones just by dividing everything, so by either sine squared or cosine squared. So if I divided everything by sine squared over sine squared is going to be 1. cosine squared over sine squared is going to be cotangent squared. And 1 over sine squared is cosecant squared. And the other one will be dividing everything by cosine. So tangent squared theta plus 1 equals secant squared theta. You don't have to know how to derive these, but you do want to be familiar with these. Okay, let theta be an acute angle such that cosine of theta equals 0.8. Find the values of sine of theta and tangent of theta using trigonometric identities. Okay, so I'm going to use this identity up here because it involves cosine and sine. So since I know cosine, I can find sine. So sine squared of theta will be equal to, plus 0.8 squared equals 1. I'm just substituting in 0.8 for cosine. Okay, so sine squared of theta plus, and then let's see what 0.8 squared is. 0.8 squared is 0.64. So plus 0.64 equals 1. So let's subtract 0.64 from both sides. And we'll get sine squared of theta equals 0.36. Take the square root of 0.36, so square root of 0.36 we find is 0.6. Therefore, sine of theta equals 0.6. Now tangent's just sine over cosine, right? So tangent of theta equals sine of theta over cosine of theta. So that's going to be equal to 0.6 over 0.8. And if we divide that on our calculators, we find that it's going to be 3/4 or 0.75. Either of those answers would be fine. Okay, example 9. We're going to use these identities to make cosine of theta times secant of theta be equal to 1. Earlier, we said secant of theta was 1 over cosine of theta. So we can write this as cosine of theta times 1 over cosine of theta equals 1. And, if we multiply these, I'm going to get cosine of theta over cosine of theta, which equals 1. And cosine, anything divided by itself, is going to be 1. So 1 equals 1, and we have verified that identity. Example 10. Let's try to verify this one. Now, notice we have secant plus tangent times secant minus tangent. So there's a lot going on here. I'm going to distribute, though, because I have a difference. I have the factored form of the difference of two squares. Because I have something of the form a plus b, a minus b. So when I distribute these, secant times secant is secant squared of theta. Secant times tangent minus tangent is minus secant theta tangent theta. Tangent times secant is plus tangent theta secant theta. And tangent theta times negative tangent theta is minus tangent squared theta. Okay, so now these guys are like terms. They're going to minus 1 and positive 1, so they cancel. So I get secant squared theta minus tangent squared theta equals 1. And recall from the earlier, one of the earlier identities, let me go back for a second. Secant squared of theta, right here, is tangent squared of theta plus 1. So I'm going to replace that with tangent squared of theta plus 1. So I'll get tangent squared of theta plus 1 minus tangent squared of theta equals 1. And then these guys, they also cancel out. So I'm left with 1 equals 1, which is a true statement. So therefore, the identity has been verified. Now for 11, we're going to evaluate this angle. Okay, so this is degrees, 5 degrees, 40 minutes, 12 seconds. So let's convert this into all degrees. Now one thing you need to know is that there are 60 minutes in a degree and 60 seconds in a minute. So this is equivalent to 5 degrees plus 40 over 60 degrees plus, and then 12 over 60 squared, because there's 60 seconds in a minute and 60 minutes in a degree. So we have to divide this by 60 squared. And so let's put this in our calculators. 5 plus 40 divided by 60 plus 12 divided by 60 squared. And so we find this is 5.67 degrees. So we're going to say this is 5.67 degrees. Now we can do secant of that angle measure. Let's make sure our calculator is in degree mode. Mine's in radians, so I'm going to change that to degrees. And secant is 1 over cosine. So this is equivalent to 1 over cosine of 5.67 degrees. So 1 divided by cosine of 5.67 degrees. And that's going to give me about 1.005. Okay. So, on to application problems. Now, many of the application problems, or even trigonometric problems, they involve solving right triangles. And when we say solve a right triangle, you have to find all the angles and all the sides. Sometimes you're given some angles, sometimes you're given some sides, sometimes you're given some mixture. But in general, you're going to find all angles and all sides. So when a problem refers to an angle of elevation, you'll see this in a word problem pretty frequently. It talks about the angle formed by a horizontal line and going upwards, so it would be this angle. As opposed to the angle of depression, which talks about this horizontal line, but going downwards. Alright, so that's the difference between the two. But both of them come from the horizontal. So in example 7, we have a surveyor standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree at 71.5 degrees. Okay, so we got this guy here, and he is 50 feet from a large tree. Okay, so this is 50 feet. And he measures the angle of elevation, so this one here to the top of the tree, because we're from the horizontal going up, so that's this angle right here, is 71.5 degrees. How tall is the tree? Okay, think about what trig function relates this angle to the x and 50. Well, x is opposite that angle, and 50 is adjacent to that angle. So tangent is the function that relates the two. So we're going to say tangent of 71.5 degrees is equal to opposite over adjacent. So solving for x, we're going to multiply both sides by 50. So we get 50 times the tangent of 71.5 degrees equals x. So let's turn to our calculators. 50 times the tangent of 71.5 degrees. And we find it's about 149.43 feet tall. Oops, there you go. 149.43 feet tall. Moving right along. A couple more application problems and then we're done. So you are 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle theta between this path and the river's edge. Okay, so here you are. Alright, you're 200 yards from this river. So instead of going directly here, you'll walk 400 yards a different way. So you walked along this way, 400 yards. Not degrees, 400 yards. You want to find the angle between this path and the river's edge. So this angle here. Alright, find the acute angle theta between this path and the river's edge. So what you're trying to do then, this is going to be a right triangle, and let's think about what trig function is going to relate theta to this 200 and this 400. Well, 200 is opposite of theta, and 400 is the hypotenuse. So I think sine is going to be a good candidate, because sine of theta is opposite over hypotenuse, so 200 over 400. So sine of theta equals 1/2. And earlier we looked at that chart, and sine of theta is 1/2 when theta equals 30 degrees. So when theta is 30 degrees, sine of theta is 1/2. That goes back to that chart, the chart of 9 different things I said to be familiar with earlier. Okay, so that's theta. Find the length C of the given skateboard ramp. Alright, so we have this angle 18.4 degrees. We're given 4, which is the opposite side. This is a right angle down here, so we are indeed working with a right triangle. And we want to find C, which happens to be the hypotenuse of this right triangle. So what relates the opposite sides to the hypotenuse? Oh, that's going to be sine once again. So sine of 18.4 degrees is equal to opposite, which is 4, hypotenuse, which is C. Alright, so how do we solve for C then? It's in the denominator. We actually have to multiply both sides by C to get it out of the denominator. So now we get C times sine of 18.4 degrees equals 4. Solving for C, we have to divide both sides by sine. So it's going to be 4 over sine of 18.4 degrees. And so let's find the length of this ramp using our calculator. 4 divided by sine of 18.4 degrees. And we just find the length of the ramp is about 12.67 feet. And we're done. Thanks for watching, and we will see you in the next one.